Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rushdi Biraman. I'm from EM110 4G. My matrix number is 20192555276. Today I will like to explain about LED 4. So for this experiment LED 4, we have two parts. First part is milling and the second part is turning. So this is the specification and the part that need to be cut. So here is the step 1 until the 6, and for part 2 the step 1 until step 10. So the material that we use is still low carbon. For part 1 milling, I choose the second process, which is center drill. So the cutting tool that I use is center bit drill HSS. There has no descriptions, and the flutes is 2, and no size DC dimension, and no LF and LH dimension. So for part C, the cutter material is HSS. The cutting speed I use is 29. The end mill millimeter is 20. Machine max is 6000. The flutes like also is 2. The spindle speed is 416 RPM. The chip load and the feed rate is calculated by the calculator on the website. So we just key in all the cutter material and so on to get the value of chip load and feed rate. So for the chip load value that we get is 0.08, and the feed rate is 74 millimeter per minute. So the estimate time is, the formula of estimated time is length of cut divided by feet. So the length is 5 millimeter and the feet is 74. So the estimate time that we get is 0.066 minute. For part 2, I choose the third process, which is rough counter. So for the holder, I use the tool indexable holder right side with offset, and the cutting tool is turning insert carbide cutting tools, which is the shape is trapezium. The application is dynamic bar copying. The boring bar type is SDUC A. The size in millimeter is 32. So the cutter material is carbide. The cutting speed is 244 meter per minute. The workpiece diameter is 60 millimeter. The machine max is 6000. The cutting edge or the flute is 1. So the spindle speed is 1290 RPM. So the chip load and the feed rate is the value that we get from the website. So the chip load value is 0.521 millimeter per revolution. The feed rate is 674 millimeter per minute. So for the estimate time, 135 millimeter divided by the feed rate, which is 674 millimeter per minute. So the estimate time that we get is 0.2 minute.